In this final video of the extra contents, I would like you to focus on yet another interesting topic that you might have heard of, the twins paradox. It goes as follows. One of two twins makes a round trip at a velocity which is close to the speed of light, while the other simply awaits his brother's return, quietly on the Earth. According to the special theory of relativity, the traveler's time will appear dilated by some factor gamma, depending only on his velocity, so that, when he returns back on Earth, he will have aged less than his twin brother. However, if you reason from the point of view of the traveler, it is the Earth which is actually moving at the same velocity and in the opposite direction, so that during his trip he will think that time on Earth is slowed down. So how is it possible that both twins agree at the end of the trip that the one who has traveled is actually younger? In order to understand that this is not really a paradox, you must remember that the special relativity computations of time dilation only work in inertial reference frames. In this case, the reference frame which is inertial throughout the journey is that of the twin staying on the Earth. Now imagine that the traveling twin performs a round trip at a speed equal to 80% of the speed of light for 10 years, as measured by the twin on Earth. At the end of the journey, reasoning from the point of view of the twin on Earth, his brother will have aged less, and more precisely, only 6 years. As a matter of fact, when they meet again at the end of the journey, the traveler will be 4 years younger than his brother. The accurate description of what the traveler sees, however, can be obtained only with general relativity. In fact, his reference frame experiences acceleration in 3 different occasions. Upon departure from Earth, during braking and acceleration back towards the Earth, and during the final deceleration upon arrival back on Earth. When accelerating, he will think that a uniform gravitational field will be acting in the direction opposite to the acceleration, and so that time along this field will appear to flow slower and slower. Well, for the departure and arrival phases, the distance between the two twins is small, and therefore the relative time delay or advance is negligible, as this grows with the distance along the apparent gravity field. On the other hand, when the twin decelerates and accelerates back at a very large distance from his brother, he will see events on Earth speeding up enormously, because the Earth is a long distance away in a direction opposite to the apparent gravity field. When in uniform motion, during both legs of the journey, he will still think that time on Earth is flowing more slowly, but the effect of the Earth time acceleration observed when inverting his motion will be larger. The difference between the time delay on Earth during his uniform motion and the time advance during such an acceleration phase then explains perfectly the fact that his twin on Earth has aged more. You can find below this video some additional links on the twins paradox explanation. So, with this, we conclude our talk on the relativity theory and its consequences for space travel. I hope that these extra contents have stimulated your interest in this revolutionary theory and that you will want to learn more on this. The forum is, once again, the ideal place to start a new discussion on the topic. Thanks for watching and goodbye.